You won't even know when I'm recording. We've been here.
Yeah, we're transportation.
Where do we have to
All right, we'll run through what we gave to the judges.
take pictures?
Of course.
All right, so you know who we are.
Yeah.
We know our topic, preventing basement flooding in Cicero and Berwyn. So some background, Cicero and Berwyn are located in Chicago's southwest suburbs. From doing an investigation, we found that Cicero does not have a stormwater management plan in place, nor does it have any electronic sewer data or GIS data. From doing research on Berwyn, we found that they do have a stormwater management plan, which we used as a reference to build our project. We also found that they do have sewer data electronically and GIS data. So since the communities are so close to each other in proximity, we decided just to assume that the sewer system in Berwyn is similar to that of Cicero's, as well as the social vulnerabilities. Since they both have similar demographics, we assume the same vulnerabilities related to the flooding issues. An overview of the social vulnerability from Chicagoland. I used the methodology from a professor at the University of Iowa. He teaches a class of social vulnerability and geography, so I went through his lectures, followed his steps to figure out which areas are most socially vulnerable by comparing census data from 2011 to 2015. And you guys know I compared the poverty rates, the age, how many dependents, homeless, and I found that Chicago's west and south side are most socially vulnerable. And then from the information that we had with Berwyn, we decided to do an analysis more in depth. I'll let Empire explain.
So here are social vulnerability distribution maps of Berwyn County. They are reference from the governmental report using the techniques of GIS. So as we can see from the first map, different colors represent the different densities of all the social elements. The first one is household income. The second is house age. The third one is the potential risk of facilities. So for example, the green area represents the community with the highest household income. So you can see from the overlay and combination of the two maps. The first one on the top is the Hispanic population distribution map, and the second is the currency of flood distribution map. So as we can see from the border between the Berwyn County and Cicero County, the red and blue areas are the communities with the highest frequent occurrence of flood, and these areas are corresponding with the most dense Hispanic population. So that's completely the part of our project. So here are solutions of specific solutions to facilitate the reduction of stormwater runoffs. So we have 20 actual practical solutions. So these several solutions are selected important solutions. We have residential overhead sewers, downspout infrastructures, narrow spans. So now it's my party.
To further analyze the problem of flooding in Cicero and Berwyn, we did several number of tests. So one of the most important was the infiltration testing, which we did in 6 different locations, six different houses. We tested the front and the back, the front yard and the back yard. For this test, it mostly involves replicating a storm event and then measuring how fast will it take for the water to percolate 1.5 inches. And based on that, we'll sort of like know how not only how fast it percolates, but also what are the characteristics of the ground, and what is it needed for each household to have a faster percolation rate. One of the most important factors in the Cicero and Berwyn that affected the flooring, it was the soil properties. It's very well known that Berwyn and Cicero, they are located in a clay soil, and the clay soil is very well known for not percolating water very well. Also, how compact is the soil in this area? This could affect very much the percolation rate in each house. Now, for tests, all the percolation rates they were different, which will also determined that each household will require a different solution, right? Also, we developed a storm model, a storm management model, in which we managed to sort of like create a sample area, in which all our proposed solutions will be applied, and then we picked a main spot, and mainly a main pipe, the biggest pipe on the main streets, and we plugged all the data from this area, right? We set at different type of storms, and then we run a model with it. From here, we can tell that this is the existing conditions. These are the conditions of the area without our proposed solutions. And after our proposed solutions, we can see there was the max depth of water reduced slightly, but also the percolation, the infiltration rate improved. Right, there is more infiltration on the ground. This pattern continued in all the different storm events. Right, the max depth of flooding water decreased, and there was a very small increase in the infiltration rate. Right, but from three models, not only we can say that there was a reduction of the flood depth, but also we can determine that in these solutions might not be enough, because when we did this model in the sample area, this will only work if in the sample area everyone applies our solution, these proposed solutions. Right? So we can say that the rainwater inflow is way bigger than the rainwater outflow. Based on this, we can say that the pipe max depth is 3 feet, right? However, in just a 1 year storm, it can easily exceed capacity of the main pipe by 1 feet. Like in our proposed conditions, if everyone supplies it, it will only cause at least a 1% improvement, right? So which we mean is not enough.
And that's every neighbor.
Yes. So our solutions, they are meant to target at a micro level scale. They're meant to mitigate the property damage caused by the flooding, and sort of like grab all the water and throw it into the main sewer system. But this analysis proved that the main sewer system, in general, at least this main pipe is not able to handle just a 1 year storm. However, for a 1 and 2 year storm event, we can see that the pipe exceeds capacity. The water exceeds pipe capacity. However, we might not be able to see the flooding right away because these pipes are deep on the ground. In the sense that it takes these pipes are deep on the ground. So once the pipe exceeds capacity, the water tries to go to the surface. We assume that these pipes are deep at least 7 to 6 feet, so we won't see it right away. However, in a 5 and 10 year storm event, we should start seeing the flooding coming out into the pipes are located in the main streets, right? Because usually they're deep 7 feet on the ground, usually. However, from 0 to 3, this is the max depth of the pipe. Now, once the pipe capacity is exceeded, the water starts going to the surface. And that's when we start seeing the flooding on the main streets, which is the pipe that has the biggest capacity. So, this is how it's important to highlight that the solutions are not meant to solve the macro at a macro level, but they're meant to work at a micro level, which is mitigate the damage in the houses, grab most of the water out of the property, and take it into the main street.
So pretty much we came up with this check-fill model. So how check-fill model works is it prevents your home from being flooded or being damaged, like your basements. So how it works is that there's like a valve that's in your sewer, pretty much, and if it reaches reach the maximum capacity, it'll shut off, so the water can go in or out. So it just pretty much, if it shuts off, the water is not going to go back and into your basement like backflow. It's going to go to outside to the residential, the streets pretty much. So it pretty much, to install one, it costs about $3,500 to $5,000, depends on the company that installs it. Some cities have you have like a 50% buyout, so it's like the government pays 50% of it and you pay the other 50%. So it's pretty convenient. Also, we made like a little model how check valve works. This would be like your sewer head, and when you put a ball in here, so when you pour the water in here, the ball is gonna rise to the top, so it looks like a check valve. And then all the water will just go to the sewers. So just made like a little demonstration how that works. Our cost benefit go away.
Oh, they calculated all the cost